Okay, for the second part of the question for experiment number 6, we see that we have an equivalence point. And the equivalence point tells us that the acid and the base are in exact stoichiometric proportions at the equivalence point. If you recall, I mentioned that this is what we're going to use to our advantage in order to determine the number of moles of citric acid and the amount of citric acid in our drink mix. So, for this particular question, it wants us to calculate the moles of citric acid in the solution. So, in the previous example, we determined the moles of sodium hydroxide that we use. So, we use 0.0093 moles of NaOH. Now, for this question, it's asking us for the moles of citric acid. So, what this is simple stoichiometry. We know that if we are talking about moles of one compound, we can use stoichiometry to determine the moles of another compound using our balanced chemical reaction. So we have our balanced chemical reaction here. We can use it using stoichiometry to determine and go from moles of NaOH to moles of citric acid. So in this particular case, we know that at 23.25 mils at a 0.4 molar concentration, there is 0.0093 moles of sodium hydroxide present. But we want to go from moles of sodium hydroxide to moles of citric acid. So, in order to do that, we have to look at our balanced chemical reaction. And what we see is that for every 3 moles of NaOH, we have 1 mole of citric acid. And where I got those numbers from is in the balanced chemical reaction. We see that there's a 1 there, even though it's not written, and we have a 3 there. So, what you see happening is moles of NaOH cancel out, leaving us with moles of citric acid, which is exactly what the question is asking us for. So when we do this calculation, we get an answer of 0.0031 moles of citric acid. And we have to pay attention to our significant figures. We know that in this number, there were only 2 significant figures. And these numbers here are considered to be exact, so we do not consider them when determining sig figs because they have an infinite number of significant figures. So we know, based on our calculation, that our final answer needs to have 2 significant figures. So we can write this as 0.0031 or 3.1 times 10 to the minus 2 moles of citric acid. So, we've determined the moles of sodium hydroxide, we've determined the moles of citric acid. Now, the third part of the question asks us to calculate the mass of citric acid. So right now, we have an amount of citric acid in moles, but we need it in grams. So, we know that we have 0.0031 moles of citric acid. And in order for us to go from moles to grams, because that's what a mass indicates to us, when you see a mass here, we know we want a unit of grams, unless specified otherwise, that we're going to need the molar mass of our compound. So we're going to need to look at the periodic table. But if you look at the beginning part of this problem, we see that the molar mass of citric acid was 192.12 grams per mole. So we already have the molar mass of citric acid. This is our conversion factor, so if we set it up appropriately, we see that 192.12 grams of citric acid over 1 mole of citric acid. And if we cancel out our units, we see moles of citric acid cancel out, leaving us with grams of citric acid. So when we do our calculation, we get an answer of 0.59557 grams. But we have to account for significant figures, and in this particular case we have 2 significant figures. Here we have 5 significant figures, and since we're multiplying, we know that our final answer can only have 2 sig figs. So we know that for this question, our final answer has to be 0.60 grams of citric acid. Now, if we move on to the last part of this question, it asks us to calculate the mass percent citric acid in the drink mix using the formula given below. So, we have the mass of citric acid. We've got that. Now, we have to look, do we have the total mass of the drink mix? And if you look at the original question at the beginning, we have that as well. So we have both of these. We simply need to divide in order to obtain the percent citric acid in the drink mix. So, for the mass of citric acid, we know that we have to use the original number. We don't want to use the rounded number because that will introduce error. So we have the mass of citric acid and we divide by the total mass of the drink mix. And the initial question mentioned that the total mass of the drink mix was 0.70 grams. We then multiply by 100% and we get an answer of 85.08%. Now we have to account for significant figures. We know with this number, even though we're using all of the digits, only 2 of them are significant. We know in this number also has 2 significant figures. So that means our final answer can only have 2 significant figures. So that means our final answer for this problem is 85% citric acid.